Hello, this is Math 2270 coming to you from the College of DuPage during the summer of 2020, and the title of this lecture is Annihilator Operator Method Conclusion. So here's the problem I left you with last time. I hope you solved it, but maybe you got interrupted or distracted, and so you have a chance to do it again. You know what to do. Let's see how you did. Okay, now this side is d squared plus 1. And so we need to get our complementary solution from this. But now we're going to take this d squared plus 1 and we're going to annihilate this. Now to annihilate this one, I have to add another d squared plus 1. So this becomes d squared plus 1 whole squared. I also have to annihilate this guy, which means I have to have a factor of d squared plus 4. So this is what I'm going to be working with as my first homogeneous equation. This will give me my complementary solution, and we'll worry about those soon. Okay, so the complementary function solution is this one, and this was the annihilator of the right-hand side, so that means the particular solution is going to be all of these things. Now this is going to give us 4 equations in 4 unknowns. There is some serious work here, but we're going to substitute this into the differential equation and match things up. So this is what I will get, and I start matching things up. And so I find when I solve these that A is 2, B is 0, C is minus 8 over 3, and D is 0. So you see my solution then is going to be C1 times, this is the complementary solution, and this is my particular solution. And when I take a derivative, I get this. And there are some product rules involved in taking that derivative and chain rules. Make sure you're following these steps. And then I'm going to plug in my initial conditions into these two, and I get 2 equations and 2 unknowns. A lot of algebra here isn't there. And so we get these values for C1 and C2. And so the solution is this. Cool, huh? Here's another problem for you to do, and this is a 3rd order differential equation. You know what to do? Let's see how you did. Okay, this left-hand side factors this way, and that means that I will have solutions that will look like this for my complementary solution. Make sure you understand all of this. Now I need to take this left-hand side and annihilate all this business. Okay, and so what I had here was d minus 1 d squared plus 1 to start with, but then I have to annihilate this, and that's going to mean I need a factor of d minus 1 whole squared because I have the x there. And then I have to annihilate this. That means I'm going to do d plus 1. I have to annihilate the 7, means I have to have a d. So I'm looking at this homogeneous equation, and that tells me that this solution is going to look like this with all those constants. And actually, I'm not doing a good job of managing my constants, but we'll figure those out later. And so that's going to be okay. But anyway, this is the solution to this whole thing. Now, some of this is repeated over here. This one is repeated over here, although I'm using a different constant label, I guess. And these 2 are repeated over here as well. So I take the leftovers, shove it into the left-hand side, and equate the coefficients. You should know how to do this, and this is what you get for your particular solution if you do all of that work. Your final answer is going to be the complementary solution added to this particular solution. Now, the method of undetermined coefficients is not applicable to linear differential equations with variable coefficients. Those are harder. Nor is it applicable to linear equations with constant coefficients when g of x is not one of the functions that we talked about. So these are functions that you don't know how to annihilate. But differential equations in which the input function is more general are going to be considered in the next section, which is called variation of parameters. The operator method here was elegant, but the next thing is way elegant. It's called variation of parameters. Now more than ever, time is precious. Each day must count. Do the math. It will make you strong. Take care of yourself and of each other. God bless you all.